Integration of natural logarithms with u-du substitution. Evaluate the following integrals. Okay, so here's what you need to know. This rule. The integral of 1 over u du is equal to the natural log of the absolute value of u plus a constant. So you have to look for that pattern, 1 over u. So if we let u equal 4x minus 1, then du will equal 4 dx. Well, I don't have a 4 dx, so I'm going to put a 4 there and a 1/4 out front. So now I have the integral 1/4 1 over 4x minus 1 times 4 dx. Now notice this part here is your u, and this part here is your du. So if we do those substitutions, we could write the integral as 1/4 integral of 1 over u du. So I get 1/4 the natural log of the absolute value of u plus c. We're back substituting. I get 1/4 the natural log of 4x minus 1 plus c. You could check that using the derivative, remembering the chain rule. Alright, well this is very similar. So I'm going to let u equal 3x plus 2. So du then is 3 dx. Well, I don't really have a 3 dx, so I'm going to put a 3 there and a 1/3 out front. So I get 1/3 the integral of 1 over 3x plus 2 times 3 dx. Well, that's your du, that's your u. So I get 1/3 the integral of 1 over u du when I make my u substitutions. So that, according to rule, is 1/3 the natural log of the absolute value of u plus a constant of integration, c, or 1/3 the natural log of 3x plus 2 plus c. Let's look at a couple more. Oops. Okay, so number 3. It doesn't quite look like it fits that pattern. You know, we want to have it be integral of 1 over u du equals the natural log of the absolute value of u plus c. But if we look carefully, if I let u equal 3, let u equal, whiteout's good, admit mistakes, and just move on, x cubed plus x. So du will be 3x squared plus 1. Okay? Oh, I have a 3x squared plus 1 dx, right? So if I make my substitutions, I can make that 1 over u du. Notice that part up there was my du, and the part on the bottom was my u. So that's integral of natural log of the absolute value of u plus c, or subbing x back in, the natural log of the absolute value of x cubed plus x plus c. Okay, let's see, let u equal x squared plus 2x, so du is 2x plus 2 dx. Well, I have that, right? So that is my du, and what's left there is my u. So I get integral of 1 over u du. Well, that's the natural log of the absolute value of u plus c, or the natural log of the absolute value of x squared plus 2x plus c. Okay, last two. Okay, so again, I want that 1 over u du, because that's the natural log of the absolute value of u plus c. So if I let u equal tangent of x, let's try that, du will be secant squared of x dx. Well, that there is my du. This tan is my u, so I can do my substitutions of u and du and get 1 over u du. So that means I get natural log of the absolute value of u plus c, or the natural log of the tangent of x plus c. Okay. Now number 6 looks a little different. I think number 6 is going to follow the power rule variety. So let's see. Usually you take what's to a power. So if u is the natural log of x, then du will be 1 over x dx. Well, if I write this a little differently, you can see that's what we definitely have. So that's my du, and what's inside here is my u. So I get u to the 5th du integral, so it's u to the 6th over 6 plus c. Move my paper up, I get 1/6 u to the 6th plus c, or 1/6 the natural log of x to the 6th power plus c. And that's how you normally see it, but you could see it like this. I've seen a few books that like to put the exponent index right there. Okay? So you can see it either way.